Okay, it's too much to type quickly. So I see it as general bonding for general electric installations and general bonding for PV. Let me just explain in short. General bonding is seen as or regarded as your pipes, your gutters, your downpipes, your roof structure, every exposed conductive part of electrical installation as per 613 will be done with 2.5 millimeter earth, bare or insulated green yellow. So that's general bonding. Why I call it general bonding is everything that is metal bonded together, that is metal where any possible earthfall current can pass through, all bonded together. With the PV, it says minimum 4 millimeters. So all your PV is bonded together with 4 millimeter, and then that is then bonded to your rest of your electrical installation where you have done your general bonding to the downpipes, the gutters, and all of that. So that is just on the bonding itself. Now, with regards to your earthing system, depends on your soil resistivity, depends on your risk assessment, and it depends on the classification, the purpose thereof of your earthing arrangement as per Annex J, 865, 611, and so on, where it speaks about the size of conductors. Now, what a lot of people don't understand is, and don't really read, first of all, is 611 and 12 actually very clearly say that depends on the type of conductor that you use, you will adhere to table 625 and also to table 628. So for an example, 625, it mentions if your phase conductor is 16 millimeters, you will use a minimum of 16 millimeters. If you go up between 16 and 35 millimeters as your phase conductor, half of your phase conductor minimum of a 16. If you go up from a 35 to a 200, you will use half of your phase conductor minimum of a 35. And if you go up from 800 above, it will be half of your phase conductor minimum of a quarter of your PE conductor, which will be then, if I remember correctly, 200 millimeters square. Depends on the classification of the type of cable. Then further on in 611, 612, both on the bottom of the page. I don't have the stands open with me now, but it speaks about the type of conductor that you use, flexible arrangement, type of a conductor, or not flexible, or whatever. It actually then say that you have to refer to table 625 or 628 and use it accordingly. Now, if you look at 628, it actually explains or tell you that if your phase conductor is, for example, a 25 millimeter, then your main supply breaker is, say, a 80 amp breaker up to 100 meters. Your PE earth conductor shall be a 25 mil conductor. If you go further than 100 meters, it will go up from a 25 millimeter earth conductor up to a 35 millimeter earth conductor on an 80 amp rated circuit breaker. Now, with your risk assessment alone for surge protection, only for EX applications, it's recommended to have earth resistance below 10. So in short, if you have earth resistance based on your earth soil resistivity as per Annex J, 865 and so on, you do the testing, your earth soil resistivity starting off at, say, 920 ohms. You start with earthing arrangements with spikes and mats and earth conductive cement and so on. Do not use salt. You will come down, let's say, if you lucky, it depends on the area in South Africa, if it is Northern Cape, very rocky type of swell environment, or somewhere in the Lowveld, there are places even where the guys battle to get below 100 ohms on your earth resistance installation. Thus, at the end of the day, you do a risk assessment, you note, you take photos, and you put in earth spikes up to a point. Your earth will be saturated in a sense where you just can't go below, say, 92 ohms, based on your risk assessment that you have done, along with your so-called Faraday cage that you have built with your earthing in the bonding around your premise. That is the minimum it will go, and based on the risk assessment, that is then fine. However, then based on 611, in terms of your calculation of your PEC, along with your amp rated of your breaker, volts divided by 2 times your breaker size. Let's say you have 80 amp supply, so it's 230 divided by 160 amp breaker, the amps of the breaker, then it will come to a Z loop max total based on the calculation of 1,43762 ohms. That's in worst case scenario what is allowed for that breaker to handle. But if you do a loop, earth loop and a neutral loop, based on the explanations of how you do it, and you get to an ohm reading of 0.19 ohms, then you are fine, because you test your resistance from the transformer and back, your earth resistance and your neutral resistance of the actual cable. Now, based on the calculation, you know now that the maximum allowed is 1,43672 ohms. If you have a resistance higher than that, then you know that there's a cable fault on the supply side, earth cable or neutral cable that's missing or damaged or whatever. Along with that, in 866, it actually also tells you and explains to you that you have elevated voltage of some sort. Then you do your testing. You separate your earth and your neutral. You use external means of testing with the earth probe into the ground, not into your DB. You put your lead on the probe in the ground, in the actual soil, and your other lead on the neutral and the other lead on the earth, and then you will see a possible elevated neutral voltage or earth voltage. And as SANS explains, 25 volt, you notify. 50 volt, you notify, and you disconnect, switch off, and you issue on both instances an Annex H. Then, with regards to surge protection, lighting protection, 676 actually explains very clearly that if you have external lighting protection, you shall use the classifications accordingly as what is explained, so that with external lighting protection, you will also have the correct classification of surge protection installed. And as per Annex I, surge protection is not compulsory. However, it's all based on the risk assessment that you need to do for your installation and the area classification of your national flash density of your environment. And as of late, we will see a trend where in the Western Cape, the flash density rises substantially higher than the last data was captured, where it's actually a way more across South Africa than the 14 that was dated in our SANS, in the back of SANS after Annex Q. So in short, there are different parts of the electrical installation that you need to understand in terms of your lighting protection. As per SANS 10313, there are 2 other parts of SANS also explaining your earth arrangements for lighting and surge protection. And I also very clearly explains your classification of your surge protection, that you needed minimum 6 mil or 60 millimeter accordingly, and when you need to use what. And the same with 60364 for your PV side. Then also it speaks about your 115 flash density. If your flash density is to a certain point, you will use the specific classification of class 1 or class 2 or type 1 or type 2 type of SPDs, surge protection, lighting protection, in conjunction with the other. And also there it speaks about 6 millimeter and 16 millimeter for your surge protection, lighting protection. Now, where it speaks about 7 12311, it speaks about your neutral earth bonding. You may use external earth electrode to add to your system, which we in any case create now TT systems. Along with that, it says that you can use a minimum of 6 millimeter, but it all revert back to what I explained earlier about your 611 and 612 regarding your earth conductor, the size it should be nothing less than 6 millimeter. And then also 611 speaks about a readily accessible earthing terminal point, like an earth bar, where you make all your earthing arrangements for general bonding. So you have, let's say, earth bar based on 6.2 in terms of your size of your bus bar, so to speak. The size of your bus bar, what it should be. Then you have your 2.5s of all your general bonding connected to that bus bar or multiple bus bars, and your PV bonding will get also connected to that same earthing point of a minimum of whatever the size calculation that you need to do for your bus bar size, for your terminations. Remember 615, 66110, where it speaks about the maximum of 3 conductors provided that the current rating is correct for that earth terminal, as per 380 in SANS explains about your termination or terminal that you use. Then along with that, you will from that point use a minimum of 6 millimeter as explained in 611. That will go to your mains earth, and at the end your mains earth of 6 millimeter from your readily accessible earth terminal point of where you have bonded all your PV and your structure and your gutters and your downpipes in the roof or multiple places will get together in a 6 millimeter, and then from that point go to your mains earth in your DB, and then from that point it will be connected to your consumer earth, as SANS explained the size based on table 625 and 628, that your earth conductor shall be a minimum of whatever the calculation or based on the risk assessment and all of that together. So in the end, you have multiple sections, multiple parts. You need to understand what you're dealing with at that moment in time and apply the SANS accordingly. You can't just make a blanket rule or statement, I only use 60 millimeter or 6 millimeter. It's not practical. It's not cost effective to do that. However, in some cases, if you use bigger earth conductors, it will better your earthing system. But at the end of the day, it's based on SANS.